Hello everyone, here's a one sheet of inflection points with a lot of the important things on it. Okay, here's a graph of f with graphs. Make sure you're at this point always checking to see if you're at f prime, f double prime. How many inflection points does that have? An inflection point is when concavity changes sign, when f double prime changes sign. And so in the beginning, it's concave up and then concave down. So right around here, it changes concavity, then it's concave down and then concave up. So right around here, it changes concavity again. So we're going to say twice. Okay. But now we're looking at f prime. And since f double prime is the slope of f prime, the inflection point would be when the slope changes. So this is going up and then coming down. So right here is the first proof that there is a point of inflection, and then here's a second spot. So here we're going to say twice again. A few people say, but wait, this is a corner. You can't have an inflection point at a corner. Well, that's true if you're looking at f, but the fact that this point exists means that f prime exists here. So you will still have inflection points wherever the sign changes, assuming that the point exists on f prime. Because if the point exists, then f is differentiable. So we still want to say twice there. All right, here we're going to find the points of inflection, right? We're looking for actual points. That's going to be important to remind ourselves not to just get x equal because it's looking for inflection points. The first derivative is 4x cubed plus 12x squared minus 36x. And f double prime, which is what we want to do, is 12x squared plus 24x minus 36. And if we set that equal to 0, we can factor out a 12 and have, what's this? This is going to be 2, and this is going to be 3. So it looks like it's going to be plus 3 and minus 1. Double checking that. Taking out 12, it's going to be x squared plus 2x minus 3. So I like that. So there's actually going to be 2 points of inflection, one at -3 and one at 1. If you were to do a signed number line, you will have 2 points of inflection. If either of these had an even exponent, then it would not be a point of inflection. All right, and so you do want to actually calculate the y value. 1 plus, I'm doing this one first. 1 plus 4 is 5, minus 18 is -13. All right, that one was easy. This is going to be what? 81 minus 2754, 108. Sorry, it's getting crazy. 9 times 18, what's 9 times 18? 162, I think. All right, so -1, so this is going to be -81, -199, -189, I think. Might have gotten that wrong, but you get the idea. Here, so don't forget to always circle your answers. Where does f have inflection points? Here we're already given the first derivative, so we can say y double prime is 6x minus 1. And if you set that equal to 0, you get it, x equals 1/6. Notice the difference here. It says where. You should only say x equals 1/6. Could we find the actual point? No, not with the information given, because we're starting on the first derivative. Okay. Where does f have inflection points? Here we're going to want to do a signed number line. There's going to be an important point at 5 and at 0. If we do a test point, positive, 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 if x is large, it's going to stay positive because the 5 came from here and that has an even exponent. It is going to flip at the 0. So my only inflection points at x equals 0. Remember, and you should always label your signed number lines. It's only going to be at 0, so because this is not an inflection point. It is called a candidate for inflection, but it's not an inflection point. All right, here's a calculator problem. We're starting with f. Cannot determine f double prime with a calculator, so we'll at least need to take one derivative. And if we keep the first and take the derivative of the second plus the second times the derivative of the first. All right, that's the first derivative. We could do another derivative and look for the roots. I think it's easier just to put this into y1. So I've already done that. And, you know, I always like to hit zoom 6 to see what it looks like. And we only care for when x is less than 2. So it looks like we want this area. And if I do notice there's going to be an asymptote at 0. So for x, I should say for x, I'll say for x is less than or equal to 2 here, something like that. X is between 0 and 2. So we could look here and change our window. I think I want to just go straight to the window and say x max, x min of like -1, x max of, let's say, 3, y min of -5, y max of 5. So I was able to look at the graph. All right, that's going to go in asymptote. It's going to go forever. This was also an asymptote. So where would there be an inflection point? Well, if this is f prime, I want to know when the slope of f prime changes signs, and that's going to be there. Second calc max. I'm left of the max, then I want to get to the right of the max. Definitely right of the max, enter, enter. And we found 1.137, okay? But it's asking for a point. And because f was given, we will be able to find this y value. We found the x value. We need that. We have to store it. So we want to quit and go x stow into a. I did that wrong. All right, I have it into a. So now we want to evaluate the function. We have to go back. We don't want the derivative anymore. We want the function for x sine of x minus ln of x. And there's a way to find this without doing the vars button, and then a second calc 1, we're going to evaluate. That's what it looks like. I think it will evaluate, even though the point's up here. We want to say it x equals alpha a. And yes, we get the point 4.001, parentheses. Okay, where is f concave up? Well, we're certainly going to change this to 27x to the -1/3. F prime would be power rule, -9, x minus 5 to the -4/3. And then f double prime, this would be negative, positive. I think it's going to be 12, x minus 5 to the -7/3. So if f double prime is 12 over x minus 5 to the 7/3, odd and odd. All right, so we will have a signed number line. Right, that's not in the domain of f double prime. If x is bigger than 5, this is positive. If it's less than 5, it's negative. So where is it concave up? From 5 to infinity. That's part A. Okay, find any inflection points. There are no inflection points. All right, this would be the point of inflection if it actually existed, but there is no 5 in the original, so we'd want to say none. Looks like an inflection point, but x equals 5 is not on that graph. Okay, shown as a graph of f double prime. Where does f have inflection points? Well, if this is f double prime, we want to look at the x-axis because that's where f double prime might change signs. Not here. It's f double prime is negative below the x-axis, stays negative, but this is the only spot, and I assume that's at 3. So x equals 3 would be our answer. That's it. All right. Bye, everybody.